इको हो रही है थोड़ी सी. Okay. Yeah. Good morning. Good morning. May I have your attention, please, at the centers? Clearly?
अभी बारह बार
Engineering college. Let's confirm that whether it is your audio and video is clear.
Hello.
पीछे का नहीं लगता, नहीं चलेगा ये. ऐसे करते हैं फिर इसी पे अनाउंस कर दो. नहीं 11:30 पे अनाउंसमेंट 11:30 का कर दो या मैसेज कर दो 11:30 बजे. 1 घंटे में कुछ तो हो ही जाएगा, अगर नहीं होगा तो फिर देखते हैं क्या। हाँ जो भी है
वो तो मेरे को नहीं है ना, रात को तो
कम से कम फॉर्म तो कर देंगे भाई, 11:30 तक इसमें लिख देते हैं। तुमने खेला वो नहीं था वो हम मैसेज करते हैं टेक्निकल डिफॉल्ट है स्टार्ट द कोर फॉर्म एट 11:30 करते हैं।
తగ్గించండి వాళ్ళకి స్టార్ట్ చేయలేదు కదా
नहीं हुआ ब्रॉडकास्ट स्टॉप, चलने दो।
Good morning, friends. May I have your attention, please, at the centers? We are going to start the course. I hope that this time you are getting the audio and video clear. Can anybody of the centers please confirm that the video is clear, video and audio is clear?
Is the audio and video clear?
NEC College, Nasarpada Engineering College, can you please confirm that whether the audio and video is clear now?
Yes, sir.
Okay, thank you very much. Okay, very good. Very good morning to all of you at the centers, and welcome to this course on SolidWorks. I hope that this would be a interesting course for all of the centers. And thank you for showing your interest in this course. I thank the participants over here who have traveled so much to attend this course. And I am extremely sorry for the delay due to technical reasons. We could not to start the program at 10 o'clock. But I hope that we will cover up this lag. And now we have with us almost 6 centers at different places in all over India, and we have one center over here in our studio also. We have participants here, so I would like to welcome all the centers one by one. I will name them. That's first one is Karpakam Institute of Technology, Coimbatore. Welcome to this course. Second one is RVR and JC College of Engineering, Guntur, Andhra Pradesh. Very well, welcome to you. Next is Nasarpoda Engineering College. Welcome to this course, and they have been associated with us for quite long time. Next is Cooch Behar Government Engineering College, West Bengal. I welcome the participants from there also. Next is MBM Engineering College, Jodhpur, Rajasthan. I think, can you confirm that we are getting a audio and video clearly now?
Gmail for me.
Okay, no problem.
Yeah.
I can see you. MBM Jodhpur.
Okay, madam. Can I?
Jyoti Center, please confirm if you are hearing a voice. Your mic has been put on.
यही है ना MBM Jodhpur है ना?
Sir, I had now, sir, is it ready?
Yes, ma'am.
Okay. Thank you very much for confirming. Next is GSMIT from Mumbai. Okay, thank you. Thank you for confirmation by cheering. Thank you very much. Yeah. I hope you will all enjoy this course very much. So, meanwhile, due to the rescheduling of the inauguration sessions, so our HOD has gone for some urgent work as he has a meeting. So as soon as his meeting is over, he will join us. And meanwhile, I will start with our inauguration introduction lecture to this course. As you must be knowing that you are aware of that what SolidWorks is. I hope you have a broad idea of CAD Cam. But let us refresh what. अच्छा ये हुआ है. Sorry. Okay. So before we get into very much finer details of this software, I would like to share with you some of the CAD Cam ideas, or what is CAD Cam and what is SolidWorks, what is the position of it in it. As you must be aware of it that the SolidWorks is a software for drawing or drafting or designing. Okay, this is a 3-in-1 software. You can say this is for CAD Cam, and it is for design and it is for drafting also. because you start with a design, and you get the drawing out of it, and from the drawings or from the design itself, you get the CAM files, your computer aided manufacturing files, or your G codes and M codes are generated, right? And you decide the machine on which the job has to be done, and you don't need any interface in between, or you don't need any coding in between to write the programs, right? So that is the advantage of this software. So that's why it is now quite widely used. As you must have heard of earlier, CATIA, ProE, and these were the softwares which were very heavy actually in the size, and since they were complete for you can say, or they were on broader platforms or higher platforms, you can say, and which used to need very much your uh, uh, system requirements also of the level of your servers type of things. So they cannot be used on the PCs and like that, since they were very, very heavy programs. But this is a quite a, we can say, lighter software from the size point of view or from the operations point of view, and this can be run on a PC also, right? So because a lot many things were not required by everybody else, so this is a specially design software for, you can say, for specific applications, for certain applications, right? It is not a generalized type of software which can be used for variety of your works, or we can say components, or so what we can do in this is basically surfacing, modeling, sheet metal works, and then your part modelings, assembly. These things can be done in this software, but rest of the management things cannot be done, like you're keeping the records of the various components, or the product itself. That part is not there, so that is all dropped, because so that it can be made lighter actually, so that it requires less MB space, or giga space, we can say. Yeah. So there are several, we can say that as for the clarity of the people in the centers, this slides will tell you what I am talking about, right? So I am not going to read this all. So basically, since some of the time audio is not clear, so that's why we have kept it on the video slides also, right? So as you must be aware of that, how all these things developed. We were talking of the CATIA actually, right? So what, where do you have any idea that where the CATIA was developed actually, or by whom? Can anybody answer, please? Yeah, it is Dassault's. Nowadays, it is in talk very much. Dassault's, Rafael deal also. So, what is that company doing? Dassault's. That's whether it's a, but why it is named as CATIA, or who owns this CATIA, or who has developed actually, that from where it has developed. That's a interesting history actually about it. So this all CATIA platform was developed by Boeing actually. You must have heard of it, that Boeing is the biggest aircraft manufacturer, right? We see airplanes and it all. So this was actually their internal system of development. First, they started with the CAD, with a simple drafting of the drawings in the digital forms, right? With the AutoCAD and all that softwares, simpler softwares. But later on, when they implemented the digitalization over there, they wanted to digitalize each and everything, and they want to link from the drawing board to the dispatch of their products to the customers, right? And that digitalization needs actually bigger softwares, right? So they keep on developing the softwares, linking the drawing or the design offices with their manufacturing offices, their assembly areas, and with this development, actually they have to develop the interfaces also, right? So by drafting, as we all know that what drafting software would need, actually it needs a totally different type of things, like defining your line or point or circles or arcs, right? So it has to keep that type of data. Whereas when you come to the production, right, there you have to keep the data of that what is your machine capabilities, you know, what is the HP, what is the RPM of that machine, or what is the feed you can give, right? That type of things. So that has to be kept in mind while designing the component, right? If you design a certain component which cannot be manufactured at your facility, then it has to be offloaded, or that facility has to be created at some place, maybe at your end or at the vendor place. So these companies have a lot of vendors also, just like Maruti is a big example of it, as you must be aware of it, that when Maruti came in 80s in our country, a lot of small industries also came along with it. Those are now called as its vendors, right? Which supplies them OEM parts. No? Yeah? What is that OEM concept?
Original equipment parts.
Yes. Manufacturers. Yeah. Original equipment manufacturers. That is OEM, and parts. Then those parts which they develop, they are called as OEM parts. Right. So vendors are also part of the original manufacturers only. They are also, because whatever the seat plant is with somewhere else, right? The wiring system is with some other vendor, and what the Maruti is doing, Maruti is procuring all the things from the vendors, assembling it and making it a one unit, right? And then painting it and give it a finishing and dispatching the product, right? Which is a car, right? So this is how the any manufacturing process of a big, we can say, big equipment or any product happens like that. It may be an automobile, or it may be a aircraft also. Aircraft requires a lot of components, maybe in a lakhs type of thing, right? If you nowadays you can, if you are interested in that, how many parts that aircrafts need, or what are the number of the components, you can go to the Google Baba. I think that's a very interesting thing, that you could get all type of answers from there. So need not to remember, but you should have a broader idea that what is the size of the components, or what is the number of the components over there. So to keep the record of all those so many numbers in lakhs, or right, so how to keep the record of all those components? So it was a big mammoth task, and that has to be done in such a fashion that there is no chance of any mistake, right? Because in aircraft industry you cannot afford to have any big mistake, or any mistake, any silly mistake also you cannot afford to have, right? Because of the we don't have any alternative over there in the space, right? So it cannot be repaired there, or uh, it may be too expensive, too much expensive if you need a repair over there, because you have so much of human life involved in it, right? So as you must be knowing that airlines give a free insurance of 5 lakhs, more than 5 lakhs to every passenger, and that accounts to a heavy amount. And for air accidental it is I think 50 lakhs, right? In India now. So it becomes a huge amount if some crash happens, or some, or any even if the crash doesn't happen, or the casualties are not done, then also if the aeroplane has to make a emergency landings due to some technical faults, then it is a heavy cost to the airlines, right? Because a heavy penalty is imposed by your airports, which has to handle that emergency landings and all, and then the time loss, actually, all those things are to be calculated, right, in money terms. So Boeing and all, they are very, I can say, very much intelligent companies, right? So instead of paying these huge losses in these types of forms or penalties like that, so they have developed systems, right? And we can say these are the systems which are this Cad Cam software is the outcome of that type of system. Okay? And this all these now, which now Creo, Pro-E, and all these are for its facilitation, or from commercial point of view they have been made lighter in the versions, right, so that everybody can use it, right? Unless and until it becomes popular. Yes, we have our HOD Professor Dhami with us, so I would welcome Professor Dhami here. Yes.
Good morning.
Yeah.
So I am S.S. Dhami, professor in mechanical engineering and currently heading the department. So on behalf of the institute and our department, I welcome the participants in remote centers and in our studio. So first of all, it is very nice that Professor Jassal is organizing this course on CAD using SolidWorks. Because SolidWorks, I think, is nowadays becoming very popular. Earlier, the AutoCAD was quite popular, but now SolidWorks is gaining ground. So Professor Jassal organizes, I think, 2 to 3 courses on SolidWorks.
No,
every
this is
year.
the second time.
The second time.
We have organized.
Okay. So during the course, the various techniques that are required to do modeling using SolidWorks will be discussed, and he has also invited some experts who will interact with you. Our department has a number of modeling and analysis softwares with us, and it includes SolidWorks also. We have a 10-user SolidWorks license with us, which can be used for research and teaching purposes. So the participants in the studio, I will request them that after the afternoon session, they can come to the lab and work do hands-on practice. Similarly, the remote centers, if they have the SolidWorks licenses, they can also request their participants to work, because without practice, you will forget what you are going to learn in this week. So with these words, I'm thankful to Professor Vassal and the Educational Intelligence Studio for conducting this course, and I'm sure the course will be very useful.
Thank you very much, Professor Dami, for sparing your valuable time. And there are now 6 centers which are connected with us. This is the list of this. Yeah. Yes. Yeah. Okay. Thank you very much.
Right, okay. Thank you, Professor. Thank you, everybody.
Thank you. Okay, friends, we were discussing about the CATIA background, right, and how these things were developed at the CATIA. So we were Dassault Systems. Now you must be knowing that Dassault Systems is owned by Boeing. Yeah, it is one of the branch of it, because how they developed that with the piecemeal type of thing. They have developed a software for drafting, then for designing, then for manufacturing, and then with the integration with their sales, and as well as with their services also. As you know that service of any thing is also very important. The aeroplanes in which we travel needs a servicing certification also, and they require servicing from time to time, right? Because their service certificates are valid only for 1 year, or a flying time of 10,000 kilometers, like that. After that, they have to undergo a vigorous inspection, and anything which is not suitable to the standards, or which is as per standards, or have deteriorated or lived its life, has to be replaced, or that is to be maintained as per the standards, right? And the reason for that is the safety issue, number one, right? So safety issue is very, very important. As we can say that in teaching also, we should give more emphasis on the safeties, right? Here in the shop, in our students don't know that what is the meaning of the safety, or they don't have the feeling of that what should be the safety, as it is not in our culture. It's very difficult to teach safety, right? And we don't appreciate that what the designer has done, right? Let me give you one example. All of you are using the cars. You must have seen that most of the, or most, not most, but very quite people, number of people, they remove your headrest from the seats of the cars. Why do they? No, headrest is with the seat, right? No, it is not. It is not nothing to be done with the fatigue or like that. What is the importance of that? That why headrest is there in a car seat, or in a train seat? Why that headrest is there? You know, what is it? To support the from where? Okay, in what eventuality? It has to support. See, it has to support your spinal cord, or the last column of your spinal cord, just on your neck, right? It is intended only for an eventuality, which is an accident, right? In case of accident, at a speed of, let us say, even at 90 kilometers per hour, your body will tend to fall backwards, I think. Yeah. And in that case, that is the main purpose of it, to support the body, right, from going excessively backwards, right? Otherwise, what will happen? It will break, right? And if the neck breaks, then person may go into coma, or any we can say brain brain dead. That type of situation can happen. So it's quite a fatal type of injury, or it's a irrevocable injury can happen. But not knowingly or unknowingly, because they don't have any knowledge of that, what is the purpose of that headrest. Few people remove their headrest from the seats, as if they doesn't look quite good actually to them, right? So this is how. And if you see in aeroplane, nothing, not even a small pin is there, which is not there for a good reason actually. Yeah? So designer has to think from every point of view, that why I am putting this much load on a aeroplane, because otherwise you cannot fly, right? If you keep on increasing the load on the aeroplane, it cannot fly even, right? So it has to be any extra thing has to be removed from it. Whatever you don't think, that it has to be uh, there, very much there. So that is why there were seat belts also introduced first only in the aeroplanes, right? Even though that was quite bulkier actually, and heavy in weights, but that has to be there, because it's a must. Otherwise, if your plane goes upside down, or it turns like that, then what will happen? You may not be sitting on your chair. Yeah. So let us see, appreciate that what is the issue of the safety, and how much it is important in our life. As you must have seen, another example I can give you of like you must have seen a general electricians working, right? uh, in India, nobody works with the gloves, even though they may be touching the live wires also. Even I also used to do a lot of electrical works in my house, but I don't have gloves actually. Whereas as per standards, it has to be there. I found that in certain videos in which in the US, that even a person who are having some small workshops in their homes, there you cannot afford to have call an electrician or a plumber like that for your small things. So they have to maintain that type of small workshop in their homes also. So what they are doing is they are fully equipped with all the safety equipments, right? And they are following the instructions. And we lack the instructions also. We don't get the instructions, right? Like or we don't have a standardization of our plugs or switches like that, because you will find that some of the plug tops may be too loosened, or they may be too tights, right? So it means what? It means that the manufacturer is not giving importance to that standard actually, right? That's why it is not conforming to that standard. So the interference, whatever the interference should be there in the plug and the socket, is not maintained, right? And what is the consequence of that? We have short circuits in our houses, and as a result of that short circuit, the effect is on the line from where we are drawing the electricity, right? And see, think of that, every time switch on or switch off the appliances in our home, or ours is a one home. There are thousands of number of homes or lakhs of numbers of homes which are connected to that line. And what will be the combined effect on that line? It will have some type of errors. It will have, just like plant load factors maybe increasing, or your voltage drops. Earlier you must have observed that whenever the AC used to start, the whole it was affecting the almost the at least the houses nearby. You must have observed that type of thing, that your bulb used to fluctuate, because at that time that air conditioners were using the starting current of almost 32 amperes or 35 amperes, like that. So everything has, which is not as per standards, or which is not designed that way, it creates a lot of fuss, or as a mechanical engineer, we can say that it's like a sensible energy, right? What we call it in thermal engineering, that I just forgot that name, that which keeps on increasing. That's sensible heat, or no, not sensible heat. It's a no, not that heat, less sensible and latent heat, but it's a other term that of the universe also it keep on increasing. That is irreversibility, actually. Okay, let us not to be discussed here. Anyway, so we have seen a lot of CAD. CAD is a designing software, we can say, and CAM is a manufacturing software, and where is CAE is a term used for simulation type of software, right? So CAD is, you may be knowing that CAD is only for design and drafting. That is the thing. So for drafting, we have used almost AutoCAD, or some other softwares are also there for that application, which are not very popular. And earlier used to be there some other company also, but nowadays AutoCAD is mostly used. So what is the purpose of the CAD software? Is used for creating designs which has already been seated in the mind of the designer. It is a medium to communicate the fresh ideas arising in the mind of the designer. Yes, this is a typical definition of a CAD software. It is also a definition of the we can say here drawings. Drawing is called as a language of the engineers. So whatever is in your mind, you will keep it in a format, right? And the format used to be in whether it is in first quadrant or third quadrant, then whether you are following the left hand conventions or right hand conventions, right? Things like that. So we are communicating in a fixed language, we can say, right, which has some definitions. And the purpose of that is to keep one of the standards is so that the other person can understand it the way you have made it, right? Otherwise, what will happen? That somebody will say that I have thought that it's a left-handed, or otherwise, because from my point of view it will be left hand, and from your point of view it will be right hand. as applicable, it is very much applicable in threads like that, no? Whether the screw is left-handed or right-handed, like that. So that those confusions are not there. To avoid those confusions, we have conventions. So this is how the CAD softwares are all related to each other. As you can see that these are all SolidWorks, Creo, Pro-E, which is Pro Engineering, then AutoCAD and CATIAs. They are designed for different applications with keeping in mind the various size of the softwares which can be handled by the general people, or you can say the persons whose applications are lighter inside, right? So what is CAM? CAM is actually, full form is, CAM means that it is a computer aided manufacturing, right? So it's a simple term. So how we can manufacture with the help of a computer? So for manufacturing, what we have to give, or what we were doing with the conventional system. In conventional system, what we do is we give the drawing to the shop floor people, and they manufacture it, right? And what they will see, that what is the size of the component. From that size, what they are seeing, that how the component is to be machined, right? Or it has to be handled. First, from the whether it will be placed on the table, on the working table, on which machine it will come, or the job can be done. That all depends upon the size of the component, right? For just like for your jewelry manufacturing, you may be having a smaller working table, but for manufacturing your big car size components, you require a bigger machine, maybe shaper, planer, or a drilling machine, or any machine, right? So it all depends upon the size of the component, right? And from that, then that the operation, that what operation it has to perform, right? Whether it's a drilling, it's a milling, or a lathe work, or in lathe it can be facing, it can be simple plane turning, or taper turning, or threading, or maybe any type of job, right? Has to be done, and that has to be looked upon, that on which machine it has to be done. So that is the activity of the shop floor people. And shop floor in the bigger industries, it is also distributed. That is the job of the job planner type of planner. Job planners are there in the bigger industries, that on which machine has to be assigned which type of job, especially in the batch type of industries, which are not manufacturing regularly. Of course, in a process industry, you don't have to think about it, because you're manufacturing one or two components, or maybe one or two products like that. So you have a fully defined processes, or the components which has to be going through which of the processes. So there the processes are also defined, and the products are also defined very much. But for batch type of industries, it is not very much clear, that sometimes the job may be a bigger, and sometimes it may be a smaller in size. They all has to be adjusted From the batch, I mean that the size, the components may be required in a quantity of just like 10 or maybe at the most 100, like that. So we cannot go for a customized setup for that. We have a generalized setup in that type of industries, right? And for that type of work, that has to be done. So after planning that which machine to use and which component to be or which job to be performed where, right? Then it is handed over to your technician, right? You take the components and machine it according to the drawings which designer has produced, right? So he has defined all the parameters, that how it has to be performed and what are the tolerances in it, right? Those tolerances are to be kept in mind, right? They may be geometrical tolerances or your simple tolerances, right? So all that has to be kept in mind. So even your CAM softwares also keep those things in mind, right? So it is not that that we are giving any command to the CAM software like that. It has to be defined. That what is like when we come to the practice, we'll see that how to give or how to define your constraints in that software, right? Because as the input, that is called as the inputs given to the software, and depending upon that, it will come with a different type of solutions or instruction sheets, right? Or it will make the sequence that which operation has to be done first and then second and then third, like that. A simple example could be your step turning. In step turning also, you have to draw the sequences, that what has to be done, which step has to be done first and which step has to be done later on. So that sequencing is also one of the factor in that. So we will after all those things have kept in mind or taken into consideration, that the job can be done over there. I hope that you find it interesting, because or is it boring? Though it may be a repetition, but I just want to, because in software you have to define each and everything. See, software is a stupid box. It will ask you every question. You can say that it's a intelligent also, but it is quite stupid and boring in nature. It's like you have a subordinate who is always creating a problem for you, right? Just okay, let me give you one example of it. Suppose you have to you are just like our HOD came, right? Once we have planned this course, that this course has to be done, right? Okay, so he will give, what he will say, you do this course, right? Simply. Suppose I am not a human being and I am a machine, so I will say which course, right? So there will be a course name like that. Course name is defined at the SolidWorks. Then again, I will stop there because I am not getting the further instructions. So what next instruction he has to give? And what should be the course contents, right? Then course contents means you have to define that everything. This is the chapter which is to be taught, right? And in that chapter, what to be taught? So you have to define that, and I will just feed it. Yes, this is to be taught, right? And next thing is that I will take how much time it will take. That timing is to be there. That planning has to be done. Then who will take it? Who will deliver that lecture? Right. So any expert or any speaker has to be fixed for that. For that, he has to give instruction. Right. So we have done up to that. The speaker has to be fixed, and then for that, this once, and then who will do the then the speaker may say that I am not available. What the machine will say? So you will get a error code or something like that, isn't it? With some number, and then in the software you will check that what is that error code means, because it is a machine. It whatever you have feeded in it, only that will come out of it. Nothing will come out of its own, right? So while making the software, that those error codes are also to be taken care of. That if you are not giving the correct instructions, right, or the current sequence of doing the things, then what message has to be conveyed, or will it be simply like a idiot box? It will not respond to anything else. You may be pressing all the keys and it will not give you any answer, right? Or it may not perform any of the functions or draw anything else, right? So that is how the softwares are designed or run like that. So in one way they are very stupid, right? Because they will ask you each and everything. So there is in each and every software has a what we call a interface, or the drawing area, or one of the, there is a command line also. In AutoCAD also we have a command line at the bottom. What is that command line? That is a dialog box. Whatever instructions you are giving to the software, it is coming back with a solution. But all those solutions are already fixed in it, right? It cannot give you offer you a you can say a solution which is not feeded in that software. It's because they are not artificially intelligent, right? This is a new technology which is coming, artificial intelligence or neural network or machine learning type of things. So we hope that at some point of time that our machines will be that intelligent to handle all those queries, which may be in that even if we give any instruction in the Tamil or Telugu like that, so it understands, though it may be understanding the English also. So we hope that thing happens, right? Until then, we have to follow the syntax. You must have heard of this word, syntax. What is that? It's a it is way of defining the things to the machine. That what machine will understand, we have to write that only. For example,
machine की language है.
Yes, that is why it used to be called as the your first level languages or second level, which the machine used to interfere with the other machines. And the machines which were interacting with the persons or individuals. Those were first type of languages, or on which the platforms are there, in which the softwares are being developed. Just like your CATIA is being developed in with the Oracle platform and with the C++ and that type of language. You have a query language also, SQLs. You can run in CATIA, because that may be needed to find out if you want to find out the components in that. Oh, these are some of the different type of CAM softwares. Yeah. And this is there. Let us start from the 12 o'clock sequence, like that, in a clockwise fashion. That's a SolidWorks CAM pattern. And then you have another software called Fusion 360. Then you have Power Mills. There is also another software. Then there's another software called as Sprout Cam. Then we have Siemens NX Cam, right? Then we have Master Cam also, and CamWorks. These are of course there are other softwares also for a particular type of applications, but for general purposes, these are the almost list of the softwares which covers 90% of the field, you can say. And there are various other softwares also which are not general, but they are built on these platforms. For every application, there is a different type of software, or just like your customized softwares. For example, for designing a power plant, you have a different software. Then for you can say for general planning of the your power plant, there is a different software. And for specific components in it, let us say a turbine has to be designed, then there is a totally different software maybe there for that. So all those are very, very specific and customized softwares. So we'll not go into that too much detail, but they are generally being developed on these type of platforms, using these type of as platforms. Right? CAE, computer aided engineering, and it's a fancy, catchy word. So it's nothing more than that. It's an integration of CAD and CAM all taken together, and when it is seen in the light of the whole industry, we can say it is a CAE, computer aided engineering. And if it is that the sales and other things, sales and service also, if we take into that, then it is called something called as ERP, or that type of things are there, right? So COE can be used in almost any industry and company that designs a product exposed to different environments. So what are the various industries in it? Maybe computer-aided engineering. Other product developments include automotive, airspace, plant engineering, electronics, energy, consumer goods, HVAC, and it is not that this is limited to this much only, right? So the products that can be simulated range from extremely small parts of products to very big and complex structures such as race cars, bridges, or even power plants. So this all, so it's a you can say very holistic definition of CAE. So everything comes into it. So there are different CAE softwares are also there. Some of them, the names I am also seeing for the first time because I am also not aware of it. I have not used them. These are Nastrom, ANSYS, then Patron, SolidWorks, Abacus, SimuFact. These are all CAE softwares. But SolidWorks also falls into CAM softwares also. So there is no rigid type of definition that it's not there also, because it has some intelligence in it. SolidWorks. These are some of the applications of CAE softwares. Right? This is finite element analysis. You must have heard of it, in which you do some research type of thing, I think.
Structural. Structural.
Yeah, structural also. And what is that? It's a simulation type of thing, right? It's a simulation basically. Nothing is. It's a replacement of prototyping type of thing, right? In which you do the analysis or you take the readings without destroying or without actually manufacturing the prototypes or components and testing it in the simulated form, right? So for solid things, we say it finite element analysis, and if it is in liquid states, it's called as CFD. Yeah? Though the philosophy remains the same. And then we have multi-body dynamics. Yeah, that type of thing is also there. And the objective is for optimization, because and some of the softwares are only for optimization of the parameters, right? Nowadays a lot of research is talked about that. So all of the India or the research of the engineering is done through some of these softwares only, right? Especially for the PhD purposes. Let us see what is the scope of the CAD, CAM, and CAE. These softwares help manufacturers optimize product concepts early in design processes, enabling them to significantly improve product development time and cost. Right. So this is the reason that computers have come, and nowadays you find a product which comes into market in less than 6 months or 3 months of time, and it becomes obsolete also in 3 months or 6 months, like that. Can anybody give you an example of those type of products? Right. Yeah. It's very common. We use in everyday lives. Everybody is using it now. You take the example of your cell phones. Apple is launching more than 2 to 3 models in a year. Even Samsung is also doing such type of things, right? I'm talking of a particular segment, that what type of customer. Every customer in that bracket, some maybe under 5,000, or maybe from 5,000 to 10,000, and then 10,000 to 20,000, like that, or even in the brackets of more than 50,000, like that pricing. They have almost launching 2 to 3 models. Of course, some are just they are not in every segment, just like Apple is in the higher price segment only. So how do they can come with a product in just 5 to 6 months, like that? This is all possible with the help of Cad Cam and CAE softwares, right? Because there you don't have to make the prototypes or the actual products, right? In the computer itself, we can manufacture, we can think, design, and then assemble it, right? We can check the interferences in it, any problems of the fittings and all, those can be checked in this in the software itself. And the performance, sometimes the performance can also be simulated in those type of softwares, just like in CFD softwares we are doing it with the fluids, right? So all this has happened possible because of the invention of these softwares only, right? And as far as from the students' point of view, these softwares are very much in demand in industries. You have a higher chances of getting jobs after this, after doing these courses on this, or getting familiar with these softwares. And you must be knowing that the industries are also shifting from the manual design to the production system of engineering. So there are what is the reason for that type of shifting? The main advantage is that the improvement in the quality and cost effectiveness, right? Because whatever we were manufacturing with our hands, or yes, you must have seen the examples of very much which we use in our daily life is simply look at the knives which we used to use, what our fathers used to get the quality of the knives. Yeah? At that time they were not more than you can say simple plate type of thing which is sharpened, right? And now we are getting sophisticated knives, right? With that's zigzag teeth and all, right? And they are sharpened by diamond tools, right? And they have a very high hardness also, along with the ductility maintained, right? So those type of things we see a lot of changes in the products. So definitely the quality is improving. So quality is it's just a relative term, we can say, right? It all depends upon the time at which we are talking. The quality of today, it was never thought of in the past, say 20 years back. At that time, its cost was very, very high for producing that type of quality in that type of product, right? The example maybe your pens. The earlier we were using fountain pens, right? And of course, they were good quality ones, But if you see it from a handling point of view, or from the ease of doing the work, that was difficult actually. So we can say in that terms, the quality has improved very much, and the cost has become very effective. Nowadays, if you don't even think of that, that you have lost a pen. But when I used to study, the pen's cost, or especially the Titus or the Parker pens, which at that time they were costing around 30 to 40 rupees, which was the more than the cost of sometimes the fees of the whole month for the class also, in which you may be studying. So that was a cost effectiveness part of it. So, but nowadays, even you can get a good quality pen even for 10 rupees also. So this new use and throw concept has come, right? Everything has a product life cycle. So that's why the product life cycles is constantly decreasing, right? And so with the development of that, so you have to come. That is a challenge of the manufacturer, that it has to come with new ideas. So if you take the example of the pen also, there in 30 years back, you may be having 5 or 10 brands of pen, hardly. Or they may be having 2 to 3 models each. Company may be having, so in all total of 15 to 20 types of pens you may be having type of things. But nowadays, even if you go for a single manufacturer, maybe having 100 of types of pens, and for different purposes, different types of product is available. So that is all this has happened because of nowadays we can do all the simulation and on the CAD CAM software only. It is all because of that. If we take the example of our engineering also, then a lot of improvement has been done in the tool industry. In the tooling, you must have seen that nowadays we are not using the tools or which needs sharpening, right? We are using now bits instead of that. Maybe we started with the simple HSS bits, and now we have carbide bits and diamond bits, like that of things. Everything it has improved. Earlier we used to solder those bits on the inserts. Nowadays we are just clamping them, and maybe that improvement may lead to the magnetic type of holdings also, or like that. So every time it is increasing, or we can say it is improving. So what SolidWorks as a CAD software does, as you see, this is a mechanical design automation application that leads designers quickly sketch out ideas, experiment with features and dimensions, and produce models and detailed drawings. Right? So in the afternoon session, we'll start with the demo or teachings, you can say, on the software itself. Of course, I don't handle the software actually. So a young blood will come for showing us. We have engaged our experts from the industry for this purpose, so that this course is done professionally. Not that a little bit older person like me may not be that familiar with holding or extruding those components, right? So we'll show you that how to sketch the components out of the your ideas, right? Because now what I have learned from AutoCAD when I was just started my career. At that time, we have to define it, that what from which point to which point that line has to be drawn, right? So we have to give the absolute coordinates for that line. But nowadays, in any of the software, you can just draw anywhere you want. You can start from anywhere without defining it and without picking it on the screen itself, right? So those type of, just like we were used to drawing on the paper, that we can start from anywhere else, whatever, without defining anything that this is 0 0 or 10 by 10 or something like that, without bothering those things. So so these types of changes has been done. So and in this software we can demonstrate the organized way how you use the SolidWorks software. It is structured around the basic SolidWorks document types like parts, assemblies, and drawings, right? And the example is that you can create a part before you can create a assembly, like that. So with various examples, you will see. So I think some time is left. We'll just quickly cover it. What is this? Because I'm also a professor, so bad habit of talking too much on sometimes small things also. What is a SolidWorks? It's a design automation software package used to produce parts, assemblies, and drawings. These are the you can see some of the terminologies you don't bother about it now, because as you will see in the software, so you will appreciate and better remember at that time, right? It's nothing but it's the same thing, but which we used to do it in the paperwork. It's just a computerization of that, right? So this is how it something looks like. It has a menu bars just like your any other software, command manager, then how to managing it, yeah, features like manager, design tree, and command manager, right? Where you will be interacting, the software will be interacting with you, right? So this is how starting up, right? There are various modules if you go through it. You can start from part, and once you have a part, you can go for assembly, and then you have finally you have a drawing, right, for the production purposes. When it's a modeling or right, so setting up units and all those things, we'll see it in details. I will just quickly go through it so that it's clear to you that what we will be covering, right? This is 3D object creation process. From plane you will make a block, and then by subtracting you will have a hole in it, right? This is 2D sketching, parametric modeling, right? These are the basic things, same AutoCAD principles. Anything has to be defined from point wise, from point to point. So line is defined also from this point to the next point or the some other point by a shortest distance, right? So shortest distance will always be straight only. So this is how the line is defined. So our software understood like that, and why we are sharing it with you, that the software will understand in this way only. You cannot define the way you like it, right? It will always define a line by the shortest distance only, right? So it will be always straight, and your arc will be defined as a part of circle, which will have some center and some radius or diameter, right? And then you have a tangent arc also, right? Which is tangent to maybe some line, an arc which is tangent to some line or some other body, you can say some other circle also, it can be. Again, we will see it, that whether it is to a spherical object, it can be tangent also, right? Let's see. Then we have a 3-point arc. It what by definition it will have, that it will pass through those three points, right? It is not defined that it will have this curvature and then by or the radius, it's a part of that circle. And then we have a circle for definition of circle, that is it should have a center point and a radius or a diameter. Then spline maybe it's just a combination of arcs and it is passing through some definite points, right? And a rectangle has a definition of that, it says it has two straight lines parallel to each other, and two perpendicular lines, and the area and cap in that is rectangle, right? Like that, we have to go by the definition of the standard definitions, right? So that everybody understands the same thing, right? This is all the commands, right? Mirror, fillet, chamfer, offset entities, trim, extend. This you must have done in the AutoCAD also, but slightly difference may be there, that how to do it. Only the then you have dimensioning, same dimensioning, linear, radial, angular, type of. Then with respect to relations also, horizontal, vertical, collinear, and perpendicular type of things, parallel, tangent, midpoint, coincident, concentric, symmetric, equal, choroidal. So whatever you think of that, you can think of that type of relationship that all have are there in the software. Then you have features. So what is this? This is extruder and revolve. Second one is the revolve. Okay. Then sweep and lofted. This is how you create a 3D from 2D. Then fillet and chamfers are there. And then pattern mirrors. This is a linear pattern, circular patterns, and mirroring, that type of things. Then you have a reference geometry with respect to either with respect to plane or with respect to certain axis or with respect to certain coordinate system. What we are talking of 0, 0 and all that things. That has to be some data has to be there. Right? Then viewing from which angle, and what type of thing. So display will be based on wireframes, hidden lines visible, hidden lines removed, or shaded with edges, right? And then you have a zoom to fit, pan, rotate, those type of things are there. Then you have loading the components. Again the backrest has come in this seat design, which we are talking of. This all assembly has when we'll show you, then it will be more interesting. This is only a pictorial representation. So defining mates, this is again a constraints, putting constraints, right? This is an exploded view or the assembled view you can have. This is 2D drawing of a part assembly. A drawing template and drawing formats you will have. Just like the size, orientation, what type of things, like all those things. Then you have a drawing view. What type of view? Top view, front view, right view. This is all settings with respect to the drawings only. Right? Then you have a model view also. Orientation, what type of orientation you want to fix, right? Those type of things. We have derived drawing views, projected views, auxiliary views, detail view, all whatever we have done in the drafting, it is all almost all covered. Nothing new, but to show you that what are the things, just to remind you that these are also the things we sometimes when we don't use them or don't more use them frequently, we forget. So this is all about dimensions, right? All type of things are there. So annotations are also there, right? In dimensioning. Bill of materials are, this is there. What? Hanji?
Valuing क्यों नहीं? Valuing. Valuing. Part serial number से.
हाँ सीरियल नंबर से. अच्छा हाँ वही बिल ऑफ मटेरियल्स है ना. या बिल ऑफ मटेरियल्स. We have this much, and there are more features which we have not covered. Yeah. Of course, everything cannot be covered in the intentionally. I have done some major things which you can have, so that you have an idea of what we are talking of, what you are going to have in the week's program. So if you practice it as Dhami Sab have said, then it will be easier for you. Otherwise, you can have we will have a demo type of things done here, so you can appreciate that for this time these things are possible in SolidWorks, right? So later on you can practice it as and when you find the time. So with this, we will break for lunch, and we will start the next class at 2 o'clock. And thank you very much. Till then, see you then at 2 o'clock.
इसका किस पे सेटिंग पे चेक करते थे ठीक है नहीं